Hi, welcome back to the channel. In today's video, we are going to look at how to find derivative of some functions. Now, this particular problem set is to test you on how to find the derivative of inverse functions. And how do you recognize an inverse function when you see something like this? Sine inverse, tan inverse, or cos inverse, and so on and so forth. Now we're going to see how we would approach this problem. And there are several ways to actually solve these problems. So become very creative once you watch this video and see if there are other ways you can actually approach the same problem and solve it correctly. So let's just get started into this. So the first one is we have this function y 1 minus x squared sine inverse of x. Now, if you've watched the previous videos, which the link is down below, one of the things I recommend you to do is when you see a function like this, you need to understand which rule will guide the solution of this problem. Now, you could quickly do that by substituting another variable for your functions. Now, notice that if I substitute u for 1 minus x squared and v for sine inverse of x, I would have product of two functions. I'll have u times v, which tells me I have to use product rule to solve the problem. So let's see. So u is what? 1 minus x squared, and v is what? Sine inverse of x. So we understand that what dy dx, which is y prime, right, that we need to solve is basically u v prime plus v times u prime. So we need to find u prime and we need to find v prime to complete this problem. Now, u prime is quite easy. Derivative of u with respect to x, that is u prime, right? And it's basically easy, which is just derivative of 1, which is 0, and derivative of minus x squared, which is minus 2x. So you have 0 minus 2x, which is minus 2x, right? So derivative of this is just minus 2x. All right. Now, the one that is a little bit difficult to calculate is v, derivative of v with respect to x. Now, notice that what this is inverse function differentiation. So how do we approach inverse function differentiation? So what we do is, first of all, we write this in terms of sine v is equal to x. Okay. Now, the basic trick in doing inverse differentiation is this. So if I ask you to find dy dx, notice that this is something as saying 1 over dx dy. Okay, so instead of finding dy dx, all we need to do first is to find the x dy, and then we take the reciprocal of that to give us dy dx. So which is exactly what we're going to do. Instead of finding, so the question is to find dv dx, right? This is what we're trying to find. Okay, so what we'll do is we'll find the x dv because this is easier to find. Once we find this, then we take the reciprocal of this to give us the answer we are looking for. So let's do that. So as you can see from here, I can look at this as x is a function of v. In that case, I can find the x dv. And what will give us, what will be the x dv? The x dv would give us cosine v. Okay, so which means dv dx would now be what? 1 over cosine v. How cool is that? Okay. Now, the only thing that is remaining is this. Remember that anytime we find a derivative with respect to x, the solution has to be in terms of x. But the answer we have here is in terms of v. So somehow we need to convert this to be a function in terms of x. And how do we do that? We use this. So these identities you have to know, right? Which says that what? Sine square x plus cosine square x is equal to 1, as well as 1 plus tan square x equal to secant square x. So that's what we're going to use here. So we'll use that fact that, so when we apply this first one to this problem, note that what cosine square v plus sine square v will also be equal to 1, right? If you just change the variable from x to v. Now, which means that what cosine square v is 1 minus sine square, or rather, yes, 1 minus sine square v. So, which means that cosine v, which is what you're looking for, is square root of what? 1 minus sine square v. Now that you know this, what is sine v? We know what sine v is. Sine v is what? X, right? So this helps us to transform from cosine v to something that has to do with what? X. So sine v is x, so sine square v would be x squared. So which means that cosine v is just square root of 1 minus x squared, which gives us 1 over square root of 1 minus x squared. So this is what dv dx is, 1 over square root of 1 minus x squared. Now we are ready to solve the initial problem, y prime, which is u times v prime. What is u? U is 1 minus x squared times v prime, which is dv dx, which is times 1 over square root of 1 minus x squared. Can you see how things are coming together? Plus v, what is v? Don't forget your v. Your v is what? Sine inverse of x multiplied by u prime, which is just minus 2x. Okay, so you can basically simplify this now. 1 minus x squared over square root of 1 minus x squared plus minus 2x sine inverse of x. Now, if you like, you can simplify this one. Remember, we can write it as 1 minus 1 over 2. So if you like, you can simplify this. So square root of 1 over square root of 1 minus x squared can be written as 1 minus x squared raised to power minus 1 over 2, right? Because square root will turn to 1 over 2. And then taking it up, that will be minus 1 over 2. So when you add, multiply this using indices, this would give us 1 minus x squared raised to power 1 over 2. Okay, so you can basically write this term as what? 1 minus x squared raised to power 1 over 2 minus 2x sine inverse of x. And this can finally go as what? 1 minus x squared minus 2x sine inverse of x. So this gives us the final answer to that problem. Okay, now let's look at the second one, which is tan inverse of 2x minus 1. Okay, so let's move here. So the second problem is y equal to tan inverse of 2x minus 1. Okay, so there are a couple of ways to solve this. You could use chain rule to solve this problem. You could just look at this problem purely from inverse function point of view, which is what I think is easier to solve this problem with. So we can rewrite this as what? Tan y equal to what? 2x minus 1. Don't forget that we are asked to find dy dx. Okay, so what we are going to do is we're going to practically find the solution to this problem in a very clever way, right? So we could transform this into finding the x dy first, and then we use the x dy to find the y dx. So make x a better formula in order to find the x dy, right? You need to write x as a function of y. So which means take 1 to the other side. So you have 1 plus tan y, which means x will now be 1 over 2. So divide both. So when you divide both sides by 2, you have x equal to 1 plus tan y all over 2. Okay, so now you can find the x dy in this case. So let's just rewrite this as this, separate it to make it easy to differentiate. So dx dy is basically the differentiation of this with respect to y is 0, plus differentiation of tan y would be what? So we can take 1 over 2 out. Differentiation of tan y is just secant square y. So the answer to this is secant square y over 2. All right. Don't forget, derivative of tan y is secant square of that function of y. Okay. Now, what is dy dx? So we can easily say dy dx is going to be reciprocal of this, which is this 2 over secant square y. Fine, great. But we are not done yet, because the solution has to be in terms of x, not in terms of y. So then we use this identity, right? Secant square. So with this identity, we can quickly see that what? Secant square y is just 1 plus tan square y. Okay, so we can rewrite this as what? 2 over 1 plus tan square y. Now, what is tan? So what is tan y, right? So let's not forget that tan y is given as what? 2x minus 1. And we have to substitute this back into this equation. So which means dy dx is just 2 all divided by 1 plus 2x minus 1 square. So basically this is what you have, and then you can simplify now to give us 1 plus, when you square this, that will be 4x squared minus 4x plus 1. So just figure out how to just square this, which is 2x minus 1 times 2x minus 1. So which will give us 4x squared minus 2x plus 1, which will give us 4x squared minus 4x plus 1. So basically your final answer would be 2 plus 4x squared minus 4x. 2 is common, so you can factorize 2 out, which is 1 plus 2x squared minus 2x, right? And that will give us 1 over 1 plus 2x squared minus 2x. And this will give you your final answer, right? Okay, so this is the y dx. This is what we are asked to find. Okay, so that's the end of this particular video. There will be more videos coming up on differentiation as well as integration. So stay tuned for that. Press the bell button so that you get notification anytime I post a video on this channel, and to help you with your studies and your exams and so on and so forth, to just help you practice this skill to become very good at differentiating and integrating functions of simple of one variable. Okay, so I'll see you guys in the next video.